Okay, let's try further maths this time. Let's prove this very standard result that the sum of the first n square numbers is equal to 1 over 6n times n plus 1 times 2n plus 1, and I'm going to do this by induction. If I'm proving it via induction, my first step is to show it's true when n equals 1. Well, when n equals 1, I'm just summing the first square number, which is just 1, and that's equal to 1 over 6 times 1 plus 1 is 2, times 2 plus 1 is 3, 2 times 3 is 6, 6 over 6 is 1. Good to go. Second step, I'm going to assume it's true for when n is equal to k. So let's write this out. When n is equal to k, r equals 1 up to k of r squared is equal to 1 over 6k, k plus 1, 2k plus 1. Let's assume that's true and move on to the fun bit, step 3. We are going to take n as k plus 1, pop it into our formula and start rearranging. So I get k plus 1 r squared, r equals 1. And I'm immediately going to change this summation by splitting the k and the plus 1. This here is quite simply the summation from r equals 1 up to k plus one lot of whatever I am summing. In this case, k plus 1 squared. So I'm up to this stage, now I need to do some rearranging. Well, I've assumed that this is true from here, so I can replace this here with what I've written here and end up with 1 over 6k, k plus 1, 2k plus 1, plus k plus 1 squared. And remember, I'm trying to make it look like this, but with a k plus 1 instead of n. The way I'm going to do that is I am going to factor out a 1 over 6k out of this entire thing, or 1 over 6k plus 1 rather, out of this entire thing. So if I take it out of here, I get k times 2k plus 1. And if I take it out of here, well, 1 over 6, I'm going to need to multiply by 6. And if I take out one of the k plus 1s, I end up with this. Now, from here, I'm going to want to expand out this center slot here. You can do that. I'm sure you're more than capable, because when I expand this out, I get 2k squared plus 7k plus 6. Now I can expand that out into 1 over 6, k plus 1, that here factorizes into 2k plus 3, k plus 2, and if I look real closely, I've got my half k plus 1, not half, 1/6 k plus 1 is just the n, so that bit's sorted. Next bit, n plus 1. Well, if I look here, k plus 1, I'm sorted. Last bit, 2k plus 3, well, 2k plus 3, if I kind of meddle this around a little bit, I get that that is the same as k plus 1 times by 2 plus 1. And if I look up here, I have 2n plus 1. There's my n.